Howdy, everybody. Hope you're doing well wherever, whenever you are. We're here for day 3 of Advent of Code 2016. Gonna try and solve this one. I think the last couple days I've spent a lot of time dealing with oh, how can I do this in Rust? So we'll see. Maybe today will be the same. Or I don't know. Maybe I'll try not to go too crazy and just try and solve the problem, and we can refine it later. I think sometimes, I don't know, maybe everyone has this problem, but I think I tend to sometimes overanalyze. And I think especially if you're trying to be competitive, you obviously you need to do some analysis, but then sometimes it's just time to start programming and not worry about, efficiency until it's important. So probably a good thing to know and to learn and to work on. Anyway, I'll try and focus on that a little bit today. Anyway, with that, let's just get started. Okay, day 3, squares with 3 sides. Now that you can think clearly, you move deeper into the labyrinth of hallways and office furniture that makes up this part of Easter Bunny HQ. Okay, think clearly, I guess, because the last one you had to use the bathroom, right? Okay. This must be a graphic design department. The walls are covered in specifications for triangles. Or are they? Dun, dun, dun. This one's not long at all. The design document gives the side lengths of each triangle it describes, but 5, 10, 25. Some of these aren't triangles. You can't help but mark the impossible ones. In a valid triangle, the sum of any 2 sides must be larger than the remaining side. Oh, really? Is that true? For example, the triangle given above is impossible because 5 plus 10 is not larger than 25. Yeah, I mean, I guess that is true, because if it was, so 5 plus 10 is 15, there's no way you could get to the 2 end of the 25 points with a line that's 5 and a line that's 10. Okay, that makes sense. I think there's some kind of Amazon question I've seen before that goes around on the internet where you draw this little diagram and it turns out the only way you could do it is if the 2 poles were literally on top of each other, because there's no way for you to do it otherwise. Anyway, it's something along those lines. In your puzzle input, how many of the listed triangles are possible? Okay, this is fairly easy, so maybe part 2 will be harder. Yeah, so, okay. So I think for part 1, I just want to, all right, there's a lot of them. That being said, again, I think I just want to parse these. They are, yeah, I just parse them and then just check to make sure all of them are valid and count them up. So I could probably do that in an iterator. Does split by white space handle multiple spaces? See how there's these, this is aligned columns. Let me look that up really quick. String slices that are separated by any amount of white space. Okay, so that should work. So yeah, let's see how I can mess this up. So to parse it, oh yeah, we're gonna have a vec usize like that. Actually, I think it's actually going to be like this, right? Whereas each line is just going to be a thruple, a 3-member tuple. So for each line, we want to do let's see. We want to turn them into U sizes. And then we want to, and then we want to return like each of the three. I think I want to do it this way instead of just like a vector. Maybe I didn't make that self clear, is because I think I can, like, it'll be easier to work with them this way instead of like, you know, V1, V2, V3 is if I can just have like X, Y, and Z or whatever. So for each line, it would be L dot trim dot split white space dot map so we do that, and then we can return parts.next.unwrap 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 like that. So then we just need like a valid function. I guess a bool. So it's like a plus b, a plus b greater than c. Is that right? It is like the sum of any two sides must be larger than the remaining. So like I think I just, and a plus c is greater than b, and b plus c is greater than a. Interesting, it can't be equal then. I guess that's true. I was thinking, is it greater than or equal than? I think the answer is no, because if it were equal, then the two sides would have to be on the other side to match. So they have to be at least slightly larger to form the actual triangle. Okay, so for P1, then I think I just do input dot iter dot map like that. 1902. Too high, huh? Bummer. Okay, so what could be wrong? Oh, it's counting all of them. Like this. 982. Is that better? 30 seconds of dead air while I saw. I think this is right. I had just forgotten to filter. Can you do filter map here? What does filter map expect? Choose an iterator that both filters and maps, then return iterator yields only the values for which the supplied closure returns some value. Some, none. Okay. So these ones don't parse. So can you do like a bool to an okay and do this together then? Like, that's what I'm thinking. Dot then some. So you can do this. Okay, let's see if 982 is the correct answer. Oh. That's right. Okay, not too bad. Part one's pretty easy. I had to wait 30 seconds, so I did a little refinement. Let's try part two. Okay, so part two says, now that you've helpfully marked up their design documents, it occurs to you that the triangles are specified in groups of 3 vertically. 3 vertical. Oh, like the input is vertical. Okay. So each set of 3 numbers in a column specifies a triangle. Each set of 3 numbers in a column represents or specifies a triangle. Rows are unrelated. For example, given this following specification, the numbers with the same hundreds digit would be part of the same triangle. Yeah, so like this one, and this one. And then this one, this one, this one. In your puzzle input, and instead reading by columns, how many of the listed triangles are possible? Okay. So we just take groups of 3. And then we do each of these right here. So, we take chunks of 3. So we do this chunk, then this chunk, then this chunk. Instead, I actually don't think that's much harder. It would be input dot as slice dot chunks 3. What am I going to return it? So in here, I probably now return how many of them. So this is going to be a sum. And this is going to be... It's like let me count equals 0 if valid chunk 0 dot zero chunk 1.0 chunk 2.0 like this, like that, right? So we're doing like 1, 2, and 3. We do the first row, and then we do the same thing for the second and the third. Don't dork it up. That. What doesn't it like? Unclosed delimiter. Got an extra 0 hanging around. Oh, I need to return count here. That. That's not the whole thing. So maybe it's right. That is right. Okay. Yeah, I mean, this day wasn't nearly as hard. We could look into some ways to optimize this. Or maybe not optimize it because it only takes like microseconds. Maybe make it look cleaner. Like, see, I know you can, like, this kind of thing is really nice when you're getting these back. I don't know if you can do that with chunks. We can look. Can you it's called destructure, right? Okay, that's not what I mean though. What if the tuple itself is a vector and not a tuple? Sorry, is this too small for you guys to? You can't directly destructure it in the same way because the compiler doesn't know how many elements are inside. Yeah, this doesn't work. I presumed it wouldn't. That would be cool though. Okay, so you can use if let, index manually, matches. We could like dot map chunk to chunk 0, chunk 1, chunk 2, like that. And then we could do first, second, third. Okay. I mean, that helps a little bit. Do I have to slice it? I think I do. Oh, I don't. I used to have to slice it. So there you go. That simplifies it even further. It must like do it internally for me. Now, can I turn these into booleans? Or sorry, these booleans into usizes and do like this. Yeah, okay. Oh, I could also just change this to be a usize. So we do valid equal 1. no, here we were counting, but we can just do valid sum here, and then do these ones. I just do a map now here, and then these ones I can just go like this now. Okay, I mean, for this specific case, that looks, at least in my mind, looks cooler. So I return if it's valid and it's either a 0 or a 1. And then I can map, this one I map it to valid and sum this. This one I do it in chunks and then map the 3 valids like this. Yeah. Okay. I mean, this day wasn't too tough. Sometimes the days aren't too tough. Especially, we get to leverage the functional iterators in Rust. So, I mean, this is probably just as easy in any other language too, because you're really just looping. I don't remember it. The split white space. Like if I clippy this, I have a couple on my other days too. I'll have to. Yeah, it says I don't have to trim, at least on this one. So, okay. Anyway, there we have it. Let me know how you did. This one was fairly easy. Maybe you have some cool, I think for this day, I'd be mostly interested in, do you have some cool ways to do some checks? Maybe like this explicit thing isn't as cool. And there's some easier way to like check between the 3 numbers. There's some like cool math that you can do, otherwise, yeah, I don't think this day was too hard, but I would love to see your solutions, obviously. So let me know how you did it, and otherwise, I think we'll talk to you next time. Thanks, everybody. Bye.